Welcome everyone for day 8 of Advent to Code 2023. We're about to jump right into the puzzle, so let's go ahead and jump in. Haunted Wasteland. You are still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled Maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that that's what they are. One of the documents contains a list of left-right instructions, and the rest of the document seem to be described some kind of network of labeled nodes. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. After examining the maps for a bit, two nodes stick out, AAA and Triple Z. You feel like AAA is where you are now, and you have to follow the left-right instructions until you reach Triple Z. This format defines each node of the network individually. For example, RL and then blah. Starting with AAA, you need to look up the next element based on the next left-right instruction in your input. In this example, with AAA, and go right R by choosing the right element of AAA, which is Triple C. Then L means to choose the left element of Triple C, which is Triple Z. By following the left instruction, reach Z and Triple Z in 2 steps. Of course, you might not find Triple Z right away. If you run out of left-right instructions, repeat the whole sequence of the instructions as necessary. RL really means just RL repeating. For example, here is a situation that takes 6 steps to reach Triple Z. You start at all A's, you have triple B's both there, triple B's, triple A, triple Z. Starting at A, you go left, you get to B, you go left again to get to A, then you go right to get to B, and then you go, let's see, hold on. Okay, so B, back to A, B, A, B, and then Z. I think I counted that right. Starting at AAA, follow the instruction left, right. How many steps required? Okay, I think I'm understanding. So let's print tech. Okay, so we have that. So left, right instructions is just equal to text 0. Then yes, nodes. Are they still just pairs? Yeah. So nodes is equal to text at let's say just 2 to the end of the list. Okay. Okay. So let's make a dictionary. Nodes. Be dictionary for item in nodes. They always just triple letters. Yeah. Start equals item up to 2, I think it is. Nope, off by 1. Let's see. Left equals item from, I don't know, 6 to 9. Almost. 5 to 8. Nope. 7 to 10. There we go. Right equals item from 11 to 14. Uh, 12 to 15. Okay. Print, start, left, right. Oh my goodness, I cannot type. Okay, so taking way too long to parse through this, but whatever. So node picked at start equals left, right. And then for node in, node keys. Node at node. Okay, cool. Then really the left right instruction can be thought of as for item in left right instruction, if item will equal L and 0 else. So turn that into L's and R's into 0s and 1s. Cool. So current equals AAA while current not equal to ZZZ. We do direction equals 0. We could do, I think, current equals node dict at current at direction index. Direction equals left right instruction at direction index direction index plus equal 1 mod. Here's my mod key. Len direction index. Object and test node. Great instruction. We want to get back to the beginning of that list. Where are you working? Why is this thing out of range? Direct index. Not out by this. There we go. Steps equals 0. Steps plus equal 1. Okay, cool. I think this is right. Let's find out. Cool. That's part 1. So basically what this thing is telling us to do is that you continue to do these instructions, whatever it is, left, right, blah, blah, blah. You just keep walking through your nodes, possibly going through cycles until you reach triple Z. So to do that, I turned the left rights into zeros and ones, and then I stored these tuples as dictionary key value pair. So it's take your current node that you're on, figure out, am I going left or am I going right, and then just go there, and then just keep doing that until you reach triple Z, and then reset your left right indexing back to the beginning if you reach the end using modding by the length of that thing. So pretty easy. Part 2, the sandstorm is upon you and you aren't any closer to escaping the wasteland. You have the camel follow the instructions, but you've barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Ooh. Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the map a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number ending in Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all of the paths at the same time until they simultaneously end up at nodes that end with Z. For example, you have this. Here there are two starting nodes, 11A and 22A, because they both end with A. As you follow each left-right instruction, use that instruction to simultaneously navigate away from both nodes you are currently on. Repeat this process until all of the nodes you're currently on end with Z. If only some of the nodes you're on end with Z, they act like any other node and you continue as normal. In this example, you would proceed as follows. You're at 11A and 22A. You choose all of the left paths, leading you to 11B and 22B. Okay. You choose all the right paths, leading you to 11Z and 22Z. Okay, so you need that. So in this example, you end up entirely on nodes that end in Z after 6 steps. Okay. So first we need to find all the starting nodes. So 4 nodes in nodes dot keys print node. Okay. If nodes at the -1 plots to the end of the thing will equal a. Okay. Start nodes equals the list. Start nodes dot append nodes. And we just want to reach any of these. If node. Air Balloon, thank you very much for the tier 1 subscription. Welcome to the coding stream. Are you also an adventive coder? I know you're a Age of Empires connoisseur. Okay. I think we want this one. I don't know what's going on, but I'm here regardless. I appreciate it. We're doing Advents of Code. I would show you the commands, but my bot is broken. And I found out yesterday and haven't had a chance to fix it. But it's a daily puzzle challenge from December 1st to December 25th. And it comes out at midnight in Eastern time zone. That's what we're working on right now. So it's just coding problems, solving them as quickly as you can and such. Took 3 CS classes, so it wasn't for you. That's fair. I completely understand that. All right, so I think we want to make end nodes a set. Unix is C++. Oh, goodness. Well, that's... I might have felt the same way. So he just wants to progress through all of these starting nodes until we reach their end destinations and such. So I think we want to do something similar. Like the Zelda theme, thank you. The lo-fi Zelda music and old school RuneScape music is definitely the vibe. All right, steps is going to be 0. Current nodes is going to be X for X in start nodes. So, you know, that's our starting position. And then finish flag equals false. We already have steps. So we can do while not finish flag for item in current nodes. You finished the puzzle already, Butter? I think I'm almost there. I'm a little sleepy. Let's see. Thinkity think. Finish part 1. Gotcha. Thank you for gifting a sub to Butter Herbalim. Let's see. What am I doing right now? Direction index. Okay, so just copy this down here. I don't want this line. So do that. We'll put these at the end of this. So for item in current nodes, new nodes dot append the dictionary. What is my dictionary called? Nodes. Nope, that's not what it is. That's direction, and then we have that current nodes going to be equal to x for x in new node. And then if how would we want to do this? So we want to check to see if all of them are in the finished node destination. So we could set this equal to true, and for item in current nodes, if item not in nodes, finish flag equals false. Uh-oh. Uh-oh. I don't like that. Not finishing. How many nodes are there? Let's kill it. Nodes. Really only 5? Interesting. We want all the ones that end in Z, right? We want to go from all the ones that end with A to the ones that end with Z. And I do one at a time. Maybe that'd be smarter. Num steps from start, finish. Direction index equals 0. Steps equals 0. Finish equals set finish while current not in finish. Direction equals left, right, instruction, direction index. Current equals no dict at current. Direction index equals direction index +1. Where's my, there it is. That steps plus equals 1. Current steps. Current equals start. So we could do this, we could do that, we could do kill that. We're trying to take the old part 1 and use that for part 2. Just do one at a time, and then we could do some least common multiple stuff, I think. So num steps start nodes at 0, end nodes. Key error AAA. Line 32. Okay, yeah. So could we theoretically do this? How long would it take to do this for the big set? Not long. What is this print statement? That doesn't sound because it's not right. And we just want the least common multiple of that. Is there a least common multiple? Where am I? I don't feel like doing the math right now, which is ironic coming from the math major. Import MPy as SP. Print SP dot LCM 23. Cool. SP dot LCM. Yes. Nice. We did it. All right. Let me check my leaderboard with my friends real quick. Wrong keyboard. Beam. That makes sense. Beam. Nice. All right, cool. Let's talk about this. So the problem is basically just figuring out how many steps do you need to take to walk through your graph to get from a starting point to an ending point. And in the first part, it was just clearly one start, one end. In the second part, there were multiple starts and multiple possible ending points, not a particular one you had to get to. And so the naive approach, which I started with, was just let them all go off and figure them all out together. But the smart way to do it is to look at each start individually, let it head off until it hits a finish, and figure out how many steps it needs to take. And if not all of the starts reach a finishing node at the same time, then you just reset. And so you know that well, actually, do you know that? I might be assuming some things, but the way that I'm thinking about it is that if you just reset the cycle, you can get back to where you started if you just take a multiple of steps that it takes to get from start to finish. And so if the first node takes 2 steps to get there and the second node takes 3 steps to get there, then both nodes will get to the finish in the least common multiple number of steps. So in this case, 6. So I figured out how many steps does it take for each node individually to get to the end, and then take the least common multiple of that. which is what we came up with. I'm not sure. I might be assuming a little bit more about the problem than I should be, because let's see. Do you necessarily go back to the beginning? I don't think you do. I might have gotten lucky. But I'm not sure. I'd have to think about it to see if I was lucky or not. But all right, well that's it for day 8 of Advent to Code 2023. So yeah, today's wasn't too bad. If had to think for a moment to figure out how to not approach day 2 naively, but once we figure that out, and maybe with a little bit of luck, not sure, I'll have to go back through and rethink my logic. But we got both stars, so we did what we needed to do to finish the puzzle for today. Yeah, thanks everyone for hanging out. I appreciate you watching this video on Advent to Code Day 8 2023, and I will see you all tomorrow for Day 9 2023 Advent to Code. Take care.